This is Eureka Online, where you have the opportunity to learn all your courses or subjects with ease. And this time, I'm going to continue with mathematics, and I'm going to be taking a topic called matrix. I'm going to be taking a topic called matrix. A matrix is a rectangular arrangement. A matrix is a rectangular arrangement of numbers. Matrix is the rectangular arrangement of numbers. Now, in matrix, if we are to arrange numbers, it can be in this form. I told you, and we are going to have a square bracket where we have a A11, A12, A13, A21, A22, A23, A31, A32, A33. If we have this type, we'll call it 3 by 3 matrix. If we have this type, we'll call it 3 by 3 matrix. Why do we say 3 by 3? This is a row. We'll call it a row. This is another row. Another row. Okay? That means we're having 3 rows. Look at this. The vertical ones. We have a column. We have another column. We have another column. So that means this matrix is in 3 by 3. When we want to name it by row and column, we call the row first before the column. So we can say that this is a 3 by 3 matrix because it has 3 rows and 3 columns. Other kind of arrangement is this. So we have a 1, 2, 3, 4, 5, 6. So we have how many columns? We have a row. We have a row. Okay. So and we are having a column. We have another column. Or column, anyone. So this is 3 row and what? 3 column, 3 row and 2 column. So we call this 3 by 2 matrix. 3 by 2. So we pronounce that the row first before the column. Okay? So we can have some definitions of terms. When we talk about definition of terms, then we'll be discussing different kind of matrix that we have. Now, as we can have a column matrix. 1, 2, 3. Okay, sorry, this is a row matrix. A row matrix is a matrix that has only 1 row. A row matrix is a matrix that has only 1 row. You can also have column matrix. 1, 2, 3. A column matrix has only only one column. Only one column. That is the column matrix. So you can see that we have only one row, we have only one column. Okay. So having done this, we can also have other definitions. We can also have other definitions such as a zero matrix. A zero matrix have all its entries to be zero. Zero matrix. Zero matrix has zero matrix has all its entries to be zero. It has all its entries to be zero. It can also be called null matrix. Null matrix. It can also be called void matrix. Or we can say it can also, it can also be called empty matrix. So example of such matrix is if we have this, so 0, 0, 0, 0, 0, 0. So it is a 3 by 2. It's 3 by 2 because we have a 3 row and 2 column. So this is a void matrix. So all its entries are 0. Apart from void matrix, we can also have identity matrix or unit matrix. Identity matrix or unit matrix. Identity matrix or unit matrix is usually a square matrix. It's usually a square matrix in which the leading diagonal or the elements are the leading diagonals are 1 or 2, and elsewhere we have 0. So elements are the leading diagonals are 1 or 2. So we can have this. We have a 0, 1. Okay, sorry, we have a 1, 0, 0, 1. So this is what we call a leading diagonal. So this is identity or unit matrix. Identity or unit matrix. So apart from identity or unit matrix, we can have a matrix that is called diagonal matrix. Diagonal matrix is a matrix in which the leading diagonals have elements that is not 0, while elsewhere we have 0. Okay? So look at this. It's different from a unit matrix because the leading diagonal can be more than 1. It can be more than 1, or even usually more than 1 balance. Okay? Look at, we have a 9, 0, 0, 0, 5, 0, 0, 8, 0. Sorry, 0, 0, 8. So this is what we call diagonal matrix. Diagonal matrix. So except the leading diagonal, elsewhere we are going to be having 0. So this is the leading diagonal. This is the leading diagonal. So this is diagonal matrix. Apart from diagonal matrix, we can also have And don't forget that diagonal matrix is usually a square matrix. Yes. Diagonal matrix is usually a square matrix. So apart from diagonal matrix, we can have lower triangular matrix. Lower triangular matrix. In the lower triangular matrix, then below it, we are going to have, it's also a square matrix. It's also a square matrix, whereby I can use this below this example. So we can have 1, 0, 0, 5, 6, 5, 0, 6, 5, 0, 0, 5, 0, 0, 6, 8, 8. Okay. Coming. Let me see. So we are going to have it in this form. We are going to have it in this form. So this is what we call lower triangular matrix. Lower triangular matrix. So this is lower triangular matrix. You can see that the values that are 0 form a triangle. The values that are zeros form a triangle. While below it, we now have values that are not 0. Okay? We can also have upper triangular matrix. Upper triangular matrix. So it's opposite to lower triangular matrix, where we have the 0 to form a triangle at the below the value that are not 0. As below the value that are not 0. It's also a square matrix. It's also a square matrix. Okay, we have let's say we have a 1, 2, 3, 4, 4, 0, 0, 5, so that is 0, 0, 0. Okay. Okay. So let me say this is 5. So we have this. We have this. We have this. So this is upper triangular matrix. This is upper triangular matrix. So at the top, we have values that are what? That are more than 0. But below, we have values that are 0. And they usually form a triangle. So that's what we're saying is what? Upper triangular matrix. So having known this, there are many other definitions. Which I'll be taking them again. I will continue taking them until I finish them. Okay? So we also have there's also a matrix called transpose matrix. Transpose matrix. In a transpose matrix, the row usually become column and the column become row. So transpose matrix. Matrix is when the row become a column and the column become row. So look at this. Let's assume this is called matrix A. And we have a 1, 6, 8, 9, 8, 10, 1, 8, 11. Okay, let's assume this is a matrix given. So the transpose of a matrix is usually denoted as AT. This is transpose of a matrix. We denote it by A raised by T. So if we want to get the transpose of this matrix, we just say that all this will become a column. This second column. this third column. So look at the way I will handle it. So I'll write 1, I'll write 6, I'll write 8. So I'm done with that. That has become a column. Now, this one will also become column. We have a 9. 9 is the first, remember there, or first element. We have a 8. We have a 10. Then we have a 1. 1 is the first, followed by 8, followed by 11. So this is what we call transpose of a matrix. This is what we call transpose of a matrix. If peradventure after transposing this matrix, we're able to get the same matrix that where we are coming from, then we say we are having symmetric matrix. We say we are having symmetric matrix. So let's assume we transpose it and we give us the same thing. Then we say it's what? Symmetric. But I don't think this does not give us the same thing. Hence, it is not a symmetric matrix. It is not a symmetric matrix. Okay? So a symmetric matrix is a matrix in which if the transpose is usually the same with the element, with the main matrix given. So they must be the same. Both the number and all the column must just look alike. Must be the same. So if it's not the same, then it's not a symmetric. Though it's transpose, it's not symmetric. Okay? I hope you are following. Okay, let us see. We have other definitions such as Hermitian matrix. Hermitian matrix. Hermitian matrix. Hermitian matrix is just talking about complex numbers. It's talking about complex numbers. So if we have a complex number, then we say we are having Hermitian. In the sense that by the time we use negative sign to multiply through, and we're able to transpose it, okay? We'll be able to transpose it. If you transpose it and you give us the same thing, then we say we are having Hermitian. If you transpose it and you give us the same value as the original matrix, we say we are having what? Hermitian matrix. So first and foremost, use negative to multiply all the signs in between the complex, in between the real part and the imaginary part. When we are done with that, we transpose it. If you give out the original, we say we are having Hermitian. You can see that it's different from the other symmetric we are talking about. In the other symmetric, it will not be a complex numbers. It will not be complex number. A complex number is a number that has both the real part and the imaginary part. So we can usually have it as, let's just say we have 2 plus I. We are talking about I here. Okay? We call it imaginary. So this is a complex number. How can I have 3 minus I? So this is a complex. So when you see something like this, then we are talking about a complex number. So this is the real part, and this is the imaginary part. We usually use A plus IB to represent it. Yes. Whereby you can see that sometimes it may not just be I. We can have this to be 2 plus 4I. It's also a complex number. So it may not just be the I may have a coefficient as the one we are having here. Okay? So apart from this, so let me just quickly take an example before I progress. So if I have a matrix A to be 1 plus 1, don't forget that you don't usually separate. You only give a distance. Don't separate with comma or with semicolon. with colon, with addition, don't separate them with that, unless we are performing operation. So this is 1, then I can have 1 minus 2i. Okay? So this is 2. So I can say 4 plus 7i. Okay? So if we're able to carry out the process and we're able to get what we are talking about, then we say we are having what we need. Okay? So like I said, if we are able to get it, to have it, then we say it's not as Hamilton. So I have a minus first. Solution. A minus. So I'm just going to use minus to multiply only the place where there is a complex number, which is about I. So we don't need to use multiply 1. So I just say 1. So this is 1 plus 2i. Okay, I've already multiplied the first row. So this is 2. So 4 minus 7i. So the next thing is to now transpose it. The next is to transpose it. So that is A minus T. So this is Hamilton. So I told you when you are transposing, all the row become column, column become row. So this one, I have a 1 plus 2i. So this is 2, 4 minus 7i. So A minus transpose is not equal to A. So this is not Hamilton. This is not Hamilton. So let me see if we can give an example on the Hamilton matrix. Hamilton matrix. So this is not Hamilton because A is A minus T is not equal to A. Is not equal to A. So that's what we mean by that. So let's see some examples. So let's assume I have A to be 4, then 6 minus 2i. Then now 6 plus 2i. So I have 5. Okay. So solution A minus is equals to don't forget that before we must multiply with the minus 5 before we do transpose. Okay, so this one will give us 4, 6 plus 2i, and this one is 6 minus 2i, 5. So we now have A minus transpose, which gives us 4, 6 plus 2i, 6 minus 2i, 5. Okay? So this is, if we check, we see that from the original I have a 4, 6 minus 2i, 4, 6 minus 2i, 6 plus 2i, 6 plus 2i, 5, 5. So this is A is equals to A minus transpose. So because of that, it is Hamilton matrix, which is Hamilton matrix, because A transpose A is equal to A minus transpose. Okay? So another one we'll quickly discuss is operations on matrix. Operations on matrix. Operations on matrix. Operations on matrix. When we talk about operation on matrix, we'll be talking about addition, subtraction, division, multiplication, inverse, determinant of matrix, and so on and so forth. Okay? So we'll be taking them one after the other. We'll be taking them one after the other. So addition matrix, addition operation, addition operation. When we are carrying out addition operation of matrix, we add the A11 and A11, the A11 of A to A11 of B, the A12 of A to A12 of B. I know you understand what I mean by A11. When I started, I gave you how matrices are usually being arranged. I gave it to you. I said we have A11, A21. That means here, sorry, A12. That means we are having the first row, the first column. The first row, the second column. We have A13. Okay, the first row, you can see that is first row, the third column. So column is in this form. So this one is A21. That is what? That is second row, first column. So we have A22, second row, second column. We have A23, second row, third column. Second row, third column. So we have A31, third row, first column. We have A32. We have A32, third row for second column. We have A33, third row, third column. We have A41, fourth row, first column. We have A42, fourth row, second column. And we have A43, which is fourth row, third column. So we can have something like this. We can have something like this. So now, if we want to add, that means if we have this as a matrix, we are going to have another kind of matrix, which is matrix B. So this is A11. We want to add it to the A11 of that other matrix. This A12, we add it to A12 of the other matrix. This A13, we add it to A13 of the other matrix. This A21, like that. So that's how we add. After all, we now simplify the matrix, and we say bye-bye to that question. Okay? So that is just what we want to quickly talk about now. Even if it's a subtraction, it's the same thing. It's the same thing. So addition operation, let us quickly solve this question. Find A plus B. So this is how you see it. If matrix A equals to 1, 3, 6, 11, 5, 7, 4, 4, 3. So let's just say B, matrix B equals to 0, 1, 2, 1, 2, 1, 8, 8, 9. So A plus B now, that's solution. A plus B equals to, so I told you we are going to add A11, this A11, this A11. So 1 plus 0 is going to give us 1. Although some of you may say it's 10, but it's not 10, but 1. So we have a 3 plus 1, we have a 4. So let me just take them step by step, so that you not miscalculate them. Okay? So I said 1 plus 0, I got 1 plus 0. Okay? So 3 plus 1, 3 plus 1. So 6 plus 1, 6 plus 2, 6 plus 2. So I'm done with the first row. So the next one is 11 plus 1, 11 plus 1. 5 plus 2, 5 plus 2. 7 plus 1, 7 plus 1. So the last one there is 4 plus 8. 4 plus 8. And another 4 plus 8. And 3 plus 9. So let's just quickly complete it. So A plus B, or let me write it up. So A plus B is equals to 1 plus 0 will give us 1, 3 plus 1 will give us 4, 6 plus 2 will give us 8, 11 plus 1 will give us 12, 5 plus 2 will give us 7, 7 plus 1 will give us 8, 4 plus 8 will give us 12, 4 plus another 8 will give us 12, we have 12. So this is how to add matrices together. So this is how to add matrices together. We can also add what we call subtraction operation. Subtraction operation. Okay, before I go to subtraction operation, let me also add some alphabets so that you don't think that it's only values or numbers that we can add. Look at matrix A to be S plus Y, S minus 2Y, S, we have a Y plus 2, Y minus 2, we have a 1 plus S, 7S, 7Y. So let's assume we have this, and we have a matrix B to be S, Y, S plus Z, Y, Y minus Z, S plus 6, 1 plus Y, S, Y. So if we are being asked to add A plus B together, we don't have problem. We just say we are having this A11 plus A11. So that means I have a S plus Y plus S. We're done with that. So A12 plus A12. S minus 2Y plus Y. Done with that. So this plus this, we have a S plus Z. So we'll go further. A21 and A21. Y plus Y. A22 and A22. Y plus 2 plus Y minus Z. So A23 and A23 we added together. Y minus 2, Y minus 2, Y minus 2 plus S plus 6. So we take the last row now. 1 plus S plus 1 plus Y. 1 plus N plus 1 plus Y. Then 7 S plus S. Then 7Y plus Y. So we're able to add them. So we'll now try to check the one that has the same alphabet and the power are the same. We add them together. And that's all. So let us see. Let's see. I will wrap this up so that you'll be able to follow. So A plus B will become S plus S The power is the same, so we are going to add the coefficient. We have 1 and we have 1 here. 1 plus 1 gives us 2s plus y. So I'm done with this one. So this one is minus 2 plus y. So 2 minus 1, minus 2 plus 1 here, give us minus 1. So because y is attached, we have minus y. So this is s minus y. Okay? So this one is 1 is coefficient here, 1 is also coefficient. You can't add it to z. Z is another alphabet. So 1 plus 1 gives us 2. So that means we have a 2s plus z. So I'm done with the first row. I'm done with the first row. So taking the second row, we have a 1 here, we have 1 here. That is not visible. So 1 plus 1 gives us 2. That means we have 2y. So I have a 1 here, 1 here. So that is 2y plus 2 minus z. So in case of alphabet, that's why I'm giving you this kind of example. So this one is, that's okay. Minus 2 plus 6 will give us plus 4. That means I have a y plus s plus 4. Okay? So the last one, which is 1 plus 1 will give us 2. S plus y. So we have a 2 plus s plus y. So this is 7s plus s. 7 is the coefficient here, 1 is coefficient here. That means we have 8s. So 7 is coefficient here, 1 is coefficient here. We have a 8y. So there's nothing we can do. We can't go further than this unless if there is other kind of question that's asked. But this kind of question can lead to equality of matrix. Yes, can lead to equality of matrix. It can lead to determinant of matrix. So after all, might be asked to find the determinant. But this is where we'll leave it for now. So apart from addition of matrices or addition operation, we can also have subtraction operation. In subtraction operation, we carry out the same step as that of addition. Just that we are going to subtract. So this is subtraction operation. So subtract A11 from what? A11. A11 of A from A11 of B. So that's what we are trying to do. So that's what we do now. Let's assume we have an example. We have a 1, but don't forget that the subtraction must follow order, because in the former one, A11, A12 can be added to A11, and the arrangement will be just anyhow. But this preference is to the first element. Preference is to the first element. So that's why I have 1, 3, 10, 5, 6, 8, 1, 2, 1. Then this is the matrix A. So matrix B, I have a 1, 3, 5, 10, 11, 15, 1, 1, minus 8, 5. So if you want to find A minus B, that's question 1. Question number 2, B minus A. B minus A. So let us find A minus B. Solution. So we are going to subtract A11 from A11. So this time around I will just go straight. I've told you how to usually perform the operation. So this 1 minus 1 will give us 0. This is 3 minus 3 will give us another 0. This is 10 minus this will give us 5. Okay, so this 5 minus 10, this will give us minus 5. Minus 5. So this 6 minus 11, we have minus 5 too. We have minus 5. 8 minus 15, we have minus 7. We have 1 minus 1, we have 0. 2 minus 8. Yes. There's a minus already. But this 8 is also having minus. So if you have a 2 minus 8, it's going to give us a 2 plus 8. Because minus times minus is a plus. So this one, 2 plus 8 gives us 10. Then we also have 1 minus 5, which gives us minus 4. Okay? This is matrix of A minus B. We can also have B minus A. B minus A will be opposite of this in the so B minus A going to be 0, 0, minus 5, 5, 5, 7, 0, minus 0, 10. So that means we have B minus 8. I'm having 2 minus 8 before. So this one will now be 8 minus 8 minus 2, which is minus 10. Okay. Minus 10. We have 4. Okay. So that is B minus A. That is B minus A. So apart from subtraction operation, we also have division operation. So in the division operation, we use something like constant. We use something like constant to divide, or we can divide a matrix by another matrix. So division operation. That's when we have a matrix A equals to 1, 2, 3, 4, 5, 6. I have a B to be equals to 3, 5, 1, 2, 8, 1. So if you want to divide, you have A divided by B, which is equals to, we are going to divide A11 by A11, A12 by A12. So that means we have 1, 2, 3, 4, 5, 6 over 3, 1, 8, 5, 2, 1. So we got divided. So what do we do by that? How do we handle that? So we are going to have 1 over 3. We are also going to have, that is A divided by, so 1 over 3. We are going to have 1 over 1. So 1 over 3. So the next thing is 3 over 1. Yes. 3 over 1. 3 over 1 is 3. We also have 5 over 8. So I'm done with that. So this one will give us 2 over 5. This one will give us 4 over 2, which is 2. Which is 2. I have a 6 over 1, which is 6. So I'll be able to divide it. Okay? So we also have multiplication operation. All these can be handled with a calculator. Calculator can easily do that. So in multiplication operation, we use the row of A to multiply each of the column of B. That's why we have matrix A and B. So we use the row of A to multiply each of the column of B. So what do you mean by that? Let's assume you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or, okay, that is that way. Okay, so this is matrix A. You're going to take time, and this is matrix B. So we have maybe 1, 2, 1, 1, 1, 0, 2, 2, 5. So we are going to use this row to multiply each of the column to form the first row. Okay? Each row, this row, to multiply each of the column to form the first row. So in that kind of situation, we will just say we are performing multiplication operation. Multiplication operation. Multiplication operation. Okay, let's handle them. So let's see. That means I have an A cross B. Okay? So just follow me. Okay? Let me rub off the upper part so that there will be space enough to handle it. Don't forget that we are going to be using a row. The row here to multiply each of the column. So let's assume I have an A cross B. So I will now say all this. So we have 1 times 1. This to this first. So when I'm done, I rub it off so that you know what we are doing. So 1 times 1, 2 times 2, 3 times 2. That's 1. So sorry, 2 times 1. So this one will give us 1 times 1 will give us 1 times 1. So that we can get the first A11. If you are using it to multiply, use this to multiply this, to get the A11. So when we are done, we use this to multiply this one for A12. Use it to multiply this one for A13. When we are through, we will now pick this. We will also multiply 1 by 1. We pick this to multiply 1 by 1 to get the result. So 1 times 1 is 1. 2 times 1 is 2. We are usually write put the addition or the subtraction. 2 times 1 plus 3 times 2 times 2. So I'm done. I've used it to multiply all this. So this is my A11. So I will now leave a space. So I will now also use this to multiply this. So let me rub off this one so that you know that this is what I'm doing with the now. Okay, I will leave this here. So the next is to use this one. So 1 times 2. Don't forget to be here. To be at the first row. So 1 times 2 we have 1 times 2. We have 1 times 2. We have 2 times 1. We have 3 times 2. So I'm done with that. So I will also use the same. This one to multiply this one. So just follow me so that you don't make a mistake. So I will use it to multiply it. So 1 times 1. 1 times 1. So 2 times 0. 2 times 0. 3 times 5. 3 times 5. So I'm done with by using this. I'm done with the use of the first column to multiply all the rows. Okay? So I told you it's going to take a very, very long process. So we are going to use these two to multiply each of them 1 by 1. So I'm dealing with this, the second row. So 4 times 1, I have a 4. Don't forget that I'm going to be using to multiply 1 by 1. 4 times 1, I have 4 times 1. So 5, when I'm done, don't just use it to multiply out of them. No, don't use the first one. When you are done with this, pick this. 5 times 1, don't forget that I'm going to put the plus. Then 6 times 2. Okay? I'm done with this. Okay? Let me just use this to multiply. multiply this one. So I'm done with it now. So I will now use it to multiply the second one. Okay? So this is the next. 4 times 2 plus 4 times 2 plus 5 times 1. 5 times 1 plus 6 times 2. 6 times 2. So I'm done with that. I will give a space of the other one. So I'm multiplying this last one now. Multiplying this last one. So even if you are a kind of person that don't like calculation or you have phobia for it, so with the step I'm giving you, you'll be able to capture it. So I will also use it to multiply the 4 times 1, 4 times 1 plus 5 times 0, 5 times 0 plus 6 times 5, 6 times 5. So I'm done using this. I'm done using this. So the next thing is to use this one to multiply each of them one after. So I'm dealing with this now. So 7 times 1, 8 times 1 plus 9 times 2. So when I'm through, I will now simplify it. So I'm through with this first one. I will now use it to multiply this second one. I forgot to write, show you this. That's what I'm using. Okay? But notwithstanding, you have to understand. 7 times 2 plus 8 times 1 plus 9 times 2. So I'm through with this, but the next is to use it to multiply this last one here, this last column. So 7 times 1 plus 8 times 0 plus 9 times 5. Okay? So that's how to handle it. So I will not simplify it further. I will not simplify it further. Maybe I can, so that I can get the result. So 8 times b is equal to 1 times 1 here will give us 1. 2 times 1 here will give us 2. 3 times 2 here will give us 6. That means I have a 1 plus 2 plus 6. Okay? So 1 times 2 give us 2. 2 times 1 give us 2. 3 times 2 give us 6. I have a 2 plus 2 plus 6. So this is 1 times 1, 2 times 0, 3 times 5. That means 2 times 0 will give us 0. Okay, let me just write everything. 1 plus 0 plus 15. Okay? So the second row. So 4 times 1 will give us 4. 5 times 1 will give us 5. 6 times 2 will give us 12. 4 times 2 will give us 8. 5 times 1 will give us 5. 6 times 2 will give us 12. 4 times 1 will give us 4. 5 times 0 will give us 0. 6 times 5 will give us 30. 7 times 1 will give us 7. 8 times 1 will give us 8. 9 times 2 will give us 15. 7 times 2 will give us 14. 8 times 1 will give us 8. 9 times 2 will give us 18. 7 times 1 will give us 7. 8 times 0 will give us 0. 9 times 5 will give us 75. So A plus B, or A times B, sorry. A times B will give us 1 plus 1 plus 6 will give us 9. So this will give us 10. This will give us 16. This will give us 21. This will give us 25. That will give us 34. This will give us 30. This will give us 40, is it not 40? We have 6 plus this. So that is 10 is 40. This will give us 52. 52. Okay. Okay, 52. Okay. The multiplication of A and B give us this result. Give us this result. Okay. So that is how to multiply. That is how to multiply the matrix. So another operation is determinant of matrices. Determinant of matrices. Please pay attention very much here as you have been paying to others. So when we talk about determinant of matrix, then we are talking about magnitude. We are talking about magnitude. Okay? So we can usually use only one matrix to express or to solve question on determinant. Unless if we are to perform other operation before the determinant. Okay? So determinant of matrix, determinant of a matrix. So it's like a magnitude of a matrix. So we usually use, let's assume we have a matrix A. Determinant will give this symbol. So when you see this symbol, just know that you must find the determinant. And if it's B, if it's C, so usually use a modular symbol or magnitude symbol. So that is just how to find it. Now let's assume I have an example now. Let me take some example. Let's assume I have matrix A to be 1, 2, 3, 4, 5, 6, 0, 0, 9. Okay? Please pay attention and see how we handle it. So if you want to do for find this. That means we are looking for magnitude. So that means we just say that A equals to magnitude A equals to, we pick this one, okay, and cross this. So I'll pick 1, then I will not open a bracket, I will not cross this one. So I'll use 5 times 9. 5 times 9 is going to give me 45. 0 times 6 is going to give me 0. But that's a natural minus here. Okay? So that's a natural minus in between the cross. So I've been able to perform the first one. The next one, we are going to, there's a constant minus 2. So I'll put minus 2. There's a constant minus when you're handling this. So it means we have a plus, minus, plus. So that means I'm going to have minus 2. So when I'm dealing with this column, then I'll just leave handling it. Then I will now talk about this. I'll leave it. So I'll talk about this. You can see it. So I'll use this 4 to multiply 9. So 4 times 9 will be 36. And then 0 times 6 will give us minus 0. Okay? So I'm done with this column. So the last one I'll deal with is this column. So when I'm dealing with it, I'm going to leave this. So I'm going to multiply this thing. So that means plus 3. So apart from this second row, second column that have minus, every other one is very plus. So unless otherwise, if this one is having minus, then this one has to have minus. This one is having plus, the minus already, so I have to become plus. So that is just it. So we have a 3, 4 times 0, we have a 0 minus 0 times 5, I have another 0. So you can see that I'm not missing any step, so that you don't find any step. So this one is 45 times 45. So this one is 36 times minus 2. Going to give us minus 72. And now 3 times 0 will give us 0. So magnitude of A is equals to 45 minus 72. 45 minus 72. That should give us that 25. So it should give us 27. 27. Minus 27, but this value is higher than this. So that is about determining. So kindly subscribe to this channel, like the video, and so that you can be following and be getting information on what you need to understand and even pass excellently the course of study. Thank you.